All right, guys and gals, we are going to review the different types of slope. Let's see, am I in the picture? Yay. All right, so we're going to review the different types of slope using our foldable. Page 46 of your interactive notebook, and the foldable is going to go and be glued right on the spine. So what we're going to cover today are the 4 different types of slope that we could be seeing. How do we find slope when we see it in a graph? How do we find slope when given to a table? How do we find slope from 2 points, which is from Friday? And then I'm going to quickly teach you how to find slope given an equation. So let's go ahead and let's get started. So when we talk about finding slope in a graph, woohoo, here we go. In our song that we learned the other week, our slope writer, the difference of the y's and the difference of the x, also known as rise over run. And that is how we graph. We graph using rise over run. The rise is your y differences. So if you take a look at this graph here, we'll notice that there is a point, looks like there's a point right there, and the next point looks like it's about right there. So from those 2 given points, we would find out how far would we have to rise to reach that second point. We would rise 1, 2, 3, so that'd be plus 3. If we went downward, it would be a minus instead. So if we're rising, it's positive, just like on the y, and if it's negative, we fall. And then we either go left or right. If we go right, which we're doing here, obviously that's positive in the positive direction. And if we went backwards, it'd be in the negative direction. So we would go also a positive 2 here. So we rise, which is our plus 3, and our run, which is our plus 2. The difference of the y's and the difference of the x. So if we were to write this out in slope form, our slope would be rise over run. So that's quickly wanted just to review with you how to find the slope when you are seeing it on a graph. Just some quick things to remember. If our slope is positive, it would go from upward from left to right, puff, puff, positive. What it would look like is both numbers that make up your fraction, they'd both be positive or they would both be negative, because 2 negatives also make a positive. So our examples for that would be if you had a negative 3 over a negative 2 or a positive 3 over a positive 2. Those would both give you positive sloped lines. Okay, a negative slope is nice negative, going down from left to right. In this case, one number is negative. One number is negative. And the example we can do is either negative 3 over 2 or 3 over negative 2. Doesn't matter, only one of those numbers have to be negative in order for the slope to end up being drawn negative. So those are some clues and some helpful hints to help you when you are graphing. Okay, the next one we're going to look at is a table. So how can we look at a table and determine the slope? Remember that, again, slope is the change in the y's and the change in the x's. So if we have an f of x, which is function notation, what's another way of writing function notation is it means the same thing as y. So we have our x, y table, and all we're looking for is the change. So we talked about last week how the triangle is represented by the word change. So I'm pointing that out so that we have it in our notes. And then we just talk about the change of the x values, and then we talk about the change of the y values. So if I went down in this table, we could take a look at all the changes. To go from -1 to change from -1 to positive 2, that would be a change of plus 3. To go from 2 to 4, that would be plus 2. To go from 4 to 5 would be plus 1. And to go from 5 to 8 would be plus 3. Now, how do we go from the changes of our y's? Well, how do we go from -2 to positive 4? That'd be a positive 6. How do we go from 4 to 8? positive 4, 8 to 10, plus 2, and from 10 to 16, plus 6. So what we just got done doing is we found all the changes in the x value and we found all the changes in the y to go from one x to the next x, one y to the next y. So how does this work with slope? Well, slope is that change in the y over the change of the x. So we can actually do 1, 2, 3, whoopsie, I went up the screen, sorry. You can actually do 1, 2, 3, 4 equations and find the slope. It should work out for every single problem that we do. So let's prove it. So underneath here, we're going to do our first slope is the change of our y's over the change of our x's. So let's take a look. Our first y in our table was 6, and our first x is 3. Okay, let's keep going. But what was our next change? Our next one was 4 and 2. Our next one is 2 and 1. And our last one is 6 and 3. Okay, now, went way off, sorry guys. So if we did this correctly, all of these slopes should work out if we were to divide them. So let's go ahead and do that. 6 divided by 3 is 2. 4 divided by 2 is 2. 2 divided by 1 is 2. And 6 divided by 3 is 2. That means this table is linear because it all has the exact same rate of change. Our rate of change is 2. And remember, rate of change is the same thing as slope on a graph. If we were to graph this is the kind of graph that this would create. All right, the next one is ordered pair. And you're going to see it mostly, they're going to ask you find the slope when given 2 points. So we're going to write 2 points on the top of our flap. And let's go ahead and review what we did in class on Friday. Okay, so our 2 points is, again, this means the change in. And our formula was the difference of the y's and the difference of the x. All right, so there's the formula that we're going to be using. Remember that the y2 and the x1s and the y1s, those mean our points. So if we had 2 points given here, let's use a different color. If I had 2 points given here, x and y and x and y, the first one would be my 1 and my 1, and the next one would be a 2 and a 2. The subscripts just let you know that this x comes from the first point, this y is from the first point, this x from the second point, this y from the second. So when you plug it into your equation, you can handle it. You can figure it out. Remember, the y always goes on top, the difference of the y's and the difference of the x. Remember, it is the opposite of graphing an ordered pair, so that's always the part that tends to get tricky. All right, if you want to at this time, if you want to take a minute and you want to write down your little song, so that you have it, you can always do that. The difference of the y and the difference of the x, also known as rise over run, divide the two, and then reduce, and you have slope. Slope, 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 slope. So feel free to write that down there in your notes so you never forget it. And let's go ahead and do an example so we have something to look back to when we're doing our practice. So our slope is, this would be our x and our y, x1, y1, our x and our y, x2, y2. So now let's just do the math. Slope equals y of 2. So the second y is -6. Subtract the first y, which is -3, all over x2, which is 5, and x1 minus 2. Calculate. Just remember 2 positives, 2 negatives make a positive, so -6 plus 3 over 3, which would leave us to our slope equaling -3 over 3, which equals to 1. And there's our example of a slope, which we practiced on Friday. The last thing I want to teach you, which is really simple, is that we've been talking about slope-intercept form, and that's what this equation is. Y equals a number, x plus 5. And both of these numbers have a significant value as to how to graph this equation. And we said it was called slope-intercept form for a reason. So I'm going to switch over here real quickly. This m is your slope. It's going to be a number, whatever number is in the front, that's your slope. And the b is what number is your y-intercept, where it's crossing the y-axis at. So we're not going to really worry about the intercept this week. We just want to make sure that from an equation, you can pick out that slope every single time. So let's go ahead and do 3 examples. Switching back. So in our first problem, if we have our equation, keep going off screen on you guys, sorry about that. First equation, my slope would be right here. It's attached to the x. So my slope would be -2. Another way that you could see -2 right would be -2 over 1 or 2 over -1. Right? In the next one, we have the 1/4 attached to the x. So my slope is just simply 1/4. And then my last one, this one's tricky. There are no numbers, Mrs. Meyer, on any of these x's and y's. Remember, we can always put a 1 in front of every variable. 1x equals 1y. So what is my slope? My slope is simply 1, or you could, if you're graphing it, 1 over 1 to make it easier to graph. All right, so there are your notes for today. When you are done with your notes, Mrs. Meyer has instructions for you to get some more practice and some review on the worksheet. All right, talk to you later. Bye, guys.